This is 6-3, adding and subtracting polynomials. I'm going to jump right to an example. For adding and subtracting monomials, remember monomials are single terms. So when we add each monomial, so this monomial to that monomial to that monomial, we're looking for like terms. We can only combine like terms. So we've got 12p cubed matches 8p cubed, and 11p squared doesn't quite fit. It has to be like terms of the same variable to the same power. So when I combine these, I end up with 20. 12 plus 8 is 20p to the third plus 11p squared. And I'm writing my answer in standard form, largest degree first. So this is a degree of 3, and that's a degree of 2. Okay, in this next one, I notice that my largest degree is the x to the second power, degree of 2. So I'm looking to combine like terms. Well, there's no other x squared, so that's 5x squared. Negative 3x has no other like terms. And my constants, I'll draw a triangle around them. Negative 6 and positive 8 can be added to positive 2. So my answer is in standard form, and I've combined all the like terms. Okay, in this next one, I see that I have d squared the same. That negative 4 goes with it. So 1d squared minus 4d squared is negative 3d squared. And then the e squared. So these have the same degree. They're all a degree of 2, so I went with the alphabetical order next. And so really I have 2e squared minus 1e squared, which is a positive 1e squared. I don't need the 1 in front. So negative 3d squared plus e squared is the best answer that you can give me. It's in standard form. We're good. Okay, the next example D, 10y squared z. That can only be combined with other y squared z's, which is that and this. So they all can be combined. So basically I'm doing 10 plus 4 minus 8. 10 plus 4 is 14, minus 8 is 6 of those, 6y squared z's. So you're combining like terms. You're adding them, keeping the variables and their powers. Okay, to add polynomials, so this first one is a polynomial, specifically a binomial. And then the second grouping is a trinomial, but they're both polynomials, more than one monomial in it. So when we have groups being added together, we really don't need those parentheses. So I can go ahead and clear out those parentheses using my white colored pen here. And now I'm really just looking for those like terms again. So I've got 4m squared goes with the m squared. I went to the highest degree first. So I have 4m squared plus 1m squared, which is 5m squared. Next, I'm looking for m with no exponent, really a power of 1. So minus m. And then lastly, I have my constants 5 and positive 6, so that's plus 11. Okay, the next one is the same idea. You can just kind of ignore those parentheses instead of erasing, if that works for you guys. But I see some like terms, 10xy and negative 3xy, that's 7xy. Plus the x is not a like term with xy, and the y is not a like term with xy. When we subtract polynomials, it's a little bit different here because what we actually have is minus 1. The minus 1's a negative 1. And so we have to distribute that to the term, to the group next to it. So what I really have is x to the third plus 4y. It doesn't change anything in the front. Minus negative 1 times 2 is negative 2 x to the third. This minus that I said was really a negative. Negative 2x to the third. Now I can combine like terms. I've got an x to the third and a negative 2x to the third. So 1 minus 2 is negative 1, or negative x to the third, plus 4y. Okay, example C. Oh, I'll go to C first. So that's a negative 1, distributing to both terms. It really changes the sign. So it's negative 10x squared minus 3x plus 7. And then notice the x squared becomes negative x squared, and the negative 9 becomes positive 9, because multiplying by negative 1 just changes the sign. So combine like terms, I've got negative 10 minus 1, negative 11x squared. The x is by itself, so minus 3x, and then I have a 7 and a 9, so that's plus 16. Same thing here, I put my minus 1 here. It really is just going to end up changing the sign of the three terms in the parentheses next to it. So 7m to the fourth minus 2m squared minus 5m to the fourth plus 5m squared minus 8. So notice it's all opposite signs. Now looking for like terms, I have 7m to the fourth minus 5m to the fourth, which is 2m to the fourth. Then next I have minus 2m squared and plus 5, so that's plus 3m squared minus the constant 8. Example D, put my minus 1 there, I'm multiplying to both terms in the parentheses, so I get 9q squared minus 3q minus q squared plus 5. Remember, it just changes the sign to minus and plus. Combine like terms, I've got 9q squared and minus q squared, so that's 8q squared minus 3q plus 5, and it's in standard form.